UTME physics problem. We are given a simple pendulum which has mass m and it moves along an arc of a circle whose radius is r, and it's in a vertical plane as shown below. What is the work done by gravity in a downward swing through the angle to 0 degrees? Now, let me start by explaining what is meant by work done by gravity. Now, when it comes to work done by gravity, you see this swinging path is not really a thing of concern. What is concerned with gravity here? The work is doing is that is bringing this mass from this particular height down to this height. So it's just the same thing as it bringing this body to this level. So what matters to this guy is the level it's bringing it from. So if I draw a line, let me say I draw a line like this that is just linking this point, showing the same level. So all this line shows all the points that are on the same level with where this mass originally was. Now, all the gravity needs to do, the work it needs to do is against the distance right from this point to this point. So if you can know what the height of this point is, and you know the force, which is the force of gravity, and interpreting it, that will be the weight that this mass has, which is the mass times g. Now, that force times this distance from here to here. So let me call this distance, let me call it small letter d. Let me call it small letter d. So if you can know this, then you can find the work done by gravity. Now, how do we get that? Here's what we can do. I want you to take note of something here. Even though based on the diagram, it might not look true, but it is the truth. If you observe this very well, the length from here to this place is r. Automatically, the length from here to this place will also be r. Let me just pull that out here. Yes, the length from this place will also be r. Why is it so? It's just a simple pendulum, and then when it swings, that is why it makes an angle. Upon swinging, it looks like it is shortened. It's no longer at the same level that it was before. So that's not really something that should bother you. It's just this same thing that is swinging here and there and all of that. Now, to now get this height, what can we do? What we notice is that if the total length from this place to this place is r, then I can label the length from this place to this other end here. I can call it, let's say, L. Now, what can we say about L? You can see that the addition of L plus D will be equal to big R. The addition of L plus D will be equal to big R. Now, I'm trying to solve for D because I told you that to find the work done by gravity, all you need is this D. And the question actually wants us to solve it in terms of R. So first, this implies that D equals R minus L. But L itself is not in terms of R. So, but from what we know here, this particular thing is a right angle triangle. And I can bring that right angle triangle out. So let me just bring that out here. So with this right angle triangle, we know that the hypotenuse side is R, and then this place is L, and this place is theta. Having this relationship now, I can quickly solve for L in terms of R. Of course, this L is the adjacent to theta, and this R is the hypotenuse, so I can use cosine theta equals L over R. Cosine theta equals L over R. And what does that imply? L equals R cosine theta. Now, what does that imply? That implies that D becomes, instead of R minus L, L is now R cos theta, and that would be, since R is common, R then 1 minus cosine theta. Now, after getting this now, the next thing I want to do is that work done, as we know, work done is the product of force and distance. Is the product of force and distance. Now, what force is responsible here is the force of gravity. And the force of gravity experienced by this mass is simply the mass of this body times acceleration due to gravity. So multiply by distance. The distance I got is r then 1 minus cosine theta. So putting this together, you have mgr then 1 minus cosine theta. Yeah, that will be the work done by gravity in a downward swing through the angle theta. So if you like this video, I want you to like and subscribe. I'll see you in the next one.